Today I'll be explaining the physics of pole vaulting through one person's theoretical height. This means that one person's kinetic energy is 100% being converted into potential energy. Although in reality that is impossible due to factors such as the vibrations of the pole, technique, and friction that are also a part of one's jump. The goal of a vaulter is to transfer their running energy or kinetic energy into vertical height. The factors that go into pole vaulting are speed, height, and mass. In order to find Cody's speed, I calculated his speed within 30 meters, which was 4.47 seconds. Knowing Cody's 30 time and distance amount of 30 meters, I divided the distance by time and came up with a velocity of 6.71 meters per second. Potential energy is equal to m, mass, g, gravity due to acceleration, and h, which is height of the bar. Kinetic energy is half the mass times the velocity squared. As mentioned before, through this equation, 100% of the potential energy will be transferred into kinetic energy, so you take the two formulas and set them equal to each other, and solve for h, which would get you the theoretical height. Height equals half the velocity squared over gravity. This is what the equation looks like after I plug everything in. H equals half times 6.71 meters per second squared over 9.8 meters per second squared, which gets you h equals 2.3 meters so far. If you take a look, mass is on both sides of the equation. Automatically, the m cancels out. Excluding mass, Cody's height will be added, but not all of it. The height in pole vaulting is actually the center of mass, which is only 55% of his height, so roughly half, which should get you h equals 0.55 times Cody's height. Measuring Cody's height in meters, it is added onto the original equation. H equals 0.55 times 1.83 meters times half of 8.94 meters per second squared over 9.8 meters per second squared, which gives you the overall bar height of 5.01 meters, which translates to 16 feet and 7 inches.